Hello, my name is Jacob van Kogelenberg of JKConsult. As an extension of the podcast made for biscuit people on biscuits and packaging, I want to tell you something about the influence of sealing profiles on the sealing quality. These are the most used profiles. As you can see, we have here a longitudinal profile. It's in the direction of the product flow. Here's crossfire profile crosswise to the movement of the pack, and here the matrix. The matrix is used for such issues like pouches where we have no changes in the number of layers. Here you can see what it looks like in reality with thin film, this in longitudinal, crosswise, and the matrix. The cross seal serves to keep the product in place and to keep the atmosphere in the pack. Here you can see that the profile that was made by the fin seal discs is completely eliminated and is replaced by the cross seal. So the material that has been sealed here can be modified again. That is important. If you look at thick film, the one before was thin film, here we have thick film. You see clearly the differences between the two areas: 4-layer, two-layer area, 4-layer, 2-layer, 4-layer. And you see here you have a marked profile, and here hardly anything is seen. On top of that comes the issue of wrinkles. Here you see wrinkles. And you see this one, for example, forms a connection between the outside of the pack and the inside of the pack. So that is a leaker. Now, what does leaking mean? There is a table that has been supplied by Mr. Eric Scheller from Inolia, and this gives an overview of the time it takes for 1 cubic centimeter of water to go through a certain space. So here we have a leak of 100 micron, 100 thousandths. So this is 1/10 of a millimeter, and it takes 10 seconds. And it gets longer till we get to 0.1 micron, so 1/10 of a thousandth, and it takes over 1,000 years to get that 1 cubic centimeter of water through it. Now, the same, of course, accounts for gases. Gases go faster, so we want to avoid leakers. And one thing is to solve the issue of the different layers. So there are here crimpers that have a recessed area where the 4 layers are. In my opinion, it's a problem because we're not wrapping around a steel tube where we always have exactly the same dimensions, but we wrap around a living product. And that means that these dimensions do vary, so the recess in the crimper will sometimes match, sometimes not. Another way to solve the issue of the different layers is making a bowed crimper. It doesn't work for the gussets. The same actually is for a design of Greener company, a company that supplies very good crimpers, and they have a recessed area. It's made of 2 parts. There's a recessed area that allows the top part to be flexible. We have to recapitulate what we discussed in the last one. To make seal we need pressure and temperature simultaneously. And the problem is, how do we solve this problem of the 4 and 2-layer area? Now, the crimper profile here plays a role. What happens is you create a profile like this, and then you have intimate contact between the film and the metal. Point though is that we have here 4 layers, so the crimpers cannot get any closer. And here we have only 2 layers, so you will not have had intimate contact, direct contact of metal and film in this area, and the film, as it is stretched due to the deformation, will have intimate contact on this top of the profile. Now, what does that look in reality? In reality, we have the film stretch over those tops, and you see here a seal, and this top actually creates this seal. Now, as there is space, here there's space for film. There can be 4 layers, there even can be 6 layers. Here you stretch it, and in the stretch, in the point of contact, we transfer heat, and that is sufficient to make a seal here and in the 4-layer area. So this solves the issue. Giving a good profile gives you space for the film, so you don't crack the film, but you have sufficient contact to transfer the heat, and due to the stretching of the film, stretching here of the film and there gives pressure between the 2 layers of the film, so the good contact in between the 2 layers of film is given. What happens many times, if the seal is not good in the 2-layer area, the pressure is increased and we get this kind of effect. Here we now have a seal, but here we have damaged the material. The pressure has been too high. If we put too much pressure on it, we get more contact, more intimate contact, or you elevate the temperature to achieve in this area a good seal, and you get overheating. So a way to solve that is to move away from a very fine profile that gives you this crack to a more coarse profile that does allow the film space to move, and you get a seal here and in the 2-layer area. Now, making such a profile is not a simple job, so there are specialized companies who make those profiles. It requires highest accuracy. Another aspect is setting up and adjusting the crimpers. The best way to test it is with carbon paper, and here you see the marking in the carbon paper. It's even everywhere. We have a nice dark color. Here we have a dark color here, but it's white over there, so there's no good contact. Although the knife is cutting everywhere, so the pressure is available everywhere. The same is happening here. Here's the zigzag knife, here it's a straight knife. So that is a way to check whether the crimper is set properly. Making it more complex is if you have double crimper. So on this pack, the front one seal is made by one crimper and the back is made with another one. And here you see we have 2 tests. This one looks reasonable, although not very good on this side, but this one is not very good. They're both on the same side though, but it requires adjustment to get the even dark image with both crimpers. That only will give you good seal on both, and with a 2-up head. With a 3-up head things are even more complex, therefore you will see that 3-up crimper heads are made out of one single piece. Okay, I hope this has given you some information what the profiles mean for your package. Thank you.